All right. Good evening, everybody. All right. Let's wait for everyone to come on. We have limited time today, so we need to solve as much as questions as we can solve today. Okay, so let's just start. So everyone coming around will join us. Okay. So we stopped here in the last class. So in case you're not in the last class and you want to go through the videos, you can just um check go to our YouTube channel at gravity underscore tutorials. Go to the live section and you see the videos. The previous video we made on kinematics. Okay, so let's just solve the question. So let's try as much as possible to solve all the questions here by the left hand side. We have a lot of questions here. Let's try as much as possible to solve them today. I hope you can see the question clearly. So the question says that A is equals to 2 minus 0.1 t. All right. So if the position and the velocity at time t equals 0, so when time t equals 0, x naught is equals to 0, and v naught also is equals to 10 meter per second respectively. So what is the velocity of the car after t equals 2 seconds? So we're looking for the velocity of the car, that's the final velocity of the car. All right, when v when t is equals to 2.0, okay, 2.0 seconds. Now that don't forget that v is equals to integral a dt. Don't forget that v is equals to what? Integral a dt. Integral a dt. Are you following? That means that v is equals to integral. What is my a here? My a is 2 minus 0.1 t. 2 minus 0.1 t dt. So let's solve this. Integrate this. We have 2t minus 0.1 t raised power 2 over 2. Okay, then plus our constant c. So that is my velocity. So velocity is equals to 2t minus 0.1 t square over 2 plus c. I made a video to explain how to integrate in the previous kinematics class, so you can you can go through that. Okay, so my v now. So we're told that when v is what? When v is 10, t is 0. So let's solve for that. So this v here is 10. So that means that 10 is equals to, when v is 10, don't forget, let me color this out. When v is 10, t is what? 0. So let's put the value of t to be 0. So this will become 2 into bracket 0 minus 0.1 into bracket 0 all square over 2 plus c. Okay, so then it will be equals to everything here will give me 0. So we have C. So my C is equals to what now? Is equals to 10. What you have to find is the final velocity. So let's go again. V, let me give some space. V is equals to, what's our formula? 2t minus 0.1 t squared over 2 plus C. We have to find V now when t is 2. Whenever we see t, we put 2. This will give me V equals to 2 into bracket 2 minus 0.1 into bracket 2 all square all over 2 plus C. Don't forget we got the value for C to be what now? To be 10. I hope you're following. This will give me V equals to 4 minus, let's simplify this. 2 square will give me 4. 4 times 0.1 will give me 0.4 over 2 plus, sorry, plus 10. Okay, so V will be equals to, simplifying this, 0.4 divided by 2 should give me 0.2. So 4 minus 0.2, then plus 10, everything there should give me about 13.8. All right, so the answer here is 13.8 meter per second. 13.8 meter per second. Um, 13.8, 13.6. Okay, that's the closest. I think we approximated somewhere. So that's what led to that value. So the closest here is B. Okay, so let's move straight to the next question. If you have a question, just drop it in the comments section. Okay, let's move straight to the next question. We have a lot of questions to solve today. Okay, let's move straight to the next question. What should we pick next? What should we pick next? Let's pick this. Let's pick this. The question says, okay, so the particle moving along the x-axis is located at xi equals 2 meter at this time and xf equals 8 meter at that time. Okay, so we're giving xi to be 2 meter, and we're giving at what time? At ti equals 1 second, and also giving xf to be 8 meter at what time? At tf is 3 seconds. So find the displacement and the average velocity. This is very, very simple. Displacement, start with displacement. Displacement is change in x, okay, is equals to xf minus xi. So let's start with this. What is xf? Xf here is clearly 8 meter, and xi here is what now? Is 2 meter. That will give me 6 meter. Very, very simple. Very, very simple. So obviously the answer is D. Without solving for that, I think the answer should be D, since that's the one that has 6 meter. But let's continue. Let's complete the solution. For the average velocity, don't forget that V alpha is equals to change in x over change in t. Okay, we've gotten change in x already to be 6 meter, so that will be 6 meter over change in t simply means t1 minus t2, and t2 minus t1 either, and rather that will be tf minus ti in this case. That will give me 3 minus 1. So this will be 6 meter over 2 seconds. That will be 3 meter per second. So obviously the answer here is D. Yes, it is when you integrate 2 that you became 2t. Okay, as I said, there's a video on that. In previous class, I explained the integration. In the previous kinematics video is in the live section. Is in the just go to our playlist. You see live. So go there. You see 2 videos on kinematics. Go through them. You see how I integrated. So you simply, whenever you're integrating, the trick is when you are integrating a constant like t dt. 10 is a constant. Okay, want to integrate this, this will become 10t. So integrating a constant will revive the variable. You understand? You can just go through the video on that and all that will be clear. So next question. Okay, let's look at I want us to finish everything on kinematics today. So let's look at this. Let's look at this. Let's look at this. All right, so the question says that the acceleration question says that acceleration of a car is given as, okay, we've solved this now. We've solved this. So let's take this out. I mean, it's not the same question. Yes, it's the same question. We've solved this already. Let's take this out. Next question. Let's take a look at this one. Let's take a look at this. I hope you can see. If you can't see the question, please let me know so I can increase the size. Okay. The question says that, in case you can't see it, I'm going to read it out. I'm going to rewrite it anyway. So, an elementary particle is projected into space and traveled as, so the said r is equals to, into brackets, t raised power 3 plus 2ti. So this is clearly a vector by using unit vectors to represent them. 3 e raised power minus 2tj plus 2 sine 5tk. Okay. Now in this case, now you have to have a basic understanding on how to differentiate, and how to differentiate sine, how to differentiate sine, how to differentiate exponential functions and the rest of them. So I'll just give you a little brief that you should know. Let's do that. Okay, where should I do that now? Let's do that up or over here. Let's do that over here by the side. If y is equals to sine x, okay, so the y dx will be cos x, okay, and if y is cos x, dy dx will be minus sine x, okay. If y is e raised by x, dy dx is also e raised by x. And what else? If y is equals to ln x, dy dx will be 1 over x. Okay, so let's box this somewhere if we're going to need it. Okay. Um, please do well to share the link to your friends, classmates, and so they can join the class and not miss the class as well. What you have to find, acceleration at what time? When t is 0. So we can find acceleration. This r here is representing the displacement of the particle. Okay, and don't forget that for you to get acceleration, you simply differentiate v. Okay, so the v dt is acceleration, and also the square x over dt square is also acceleration, which means that if I differentiate displacement twice, in this case now x is r, so the square r, you understand? So if I differentiate the displacement 2 times, to give me what now? To give me acceleration. So let's do that. Let's start with differentiating it the first time. So that will give me dr dt. Okay, so dr dt, let's differentiate this part. This will give me 3t raised power 2 plus differentiate this part to give you 2, all into bracket I. And this is where maybe a little bit of problem. Okay, let us differentiate e raised power 3 e raised power minus 2t. Let me just show you that somewhere here. If I have e raised power minus 2t, it's like saying a function of a function. We have a function here. It's called algebraic function, and we have an exponential function. Okay, we call this chain rule, which is function of a function. And the shortest way, maybe I'll make a video on that. Shortest way to differentiate a function of a function is to first differentiate the inner function. Differentiate the inner function, then differentiate the outer function, then multiply your answer. So let's try that out. Differentiate this is the inner function here, like the baby function. Let's differentiate this first. What that give me? That will give me minus 2. That will give me what? That will give me minus 2. Now differentiate the outer function. Imagine that everything here is a single variable. Okay, look at this. I said when you differentiate e raised power x, just to give me what? E raised power x. So differentiating e raised power this as a single variable will give me e raised power that same thing, which is minus 2t. So differentiating everything here will give me minus 2 e raised power minus 2t. So let's bring it in here. This differentiating this part will give me minus 2 e, and write that out, minus 2 e raised power minus 2t. So multiply by minus 3, that will become, sorry, let me change the color. That will become plus 6 e raised power minus 2t. All right, then add your j, okay, then plus, now let's differentiate this part, sine 5t again. Okay, let me bring it down here, sine 5t again. This is an algebraic function, this is a trig function. All right, so the same way I did this, differentiate the inner function first, differentiate the inner function, differentiate this part, the inner function. What would that give me? That will give me 5. Okay, times, now differentiate the entire function. This is sine something. Let's go back to my rule here. Whenever you're differentiating sine something, to give you cos of that thing. Okay, so this will give me cos of what now? Of 5t. So differentiating sine 5t will give me, let me write it here, give me 5 cos 5t. Okay, I think that's clear. 5 cos 5t. So multiply that by 2, you'll be getting 10 cos 5t, and add your k, which is the unit constant, which is your unit vector. Someone asks, how is it 6? What part are you talking about? Do you mean this 6 over here? You multiply minus 2. Now when we differentiated e raised power minus 2t, we got minus 2 e raised power minus 2t. Then minus 2 times minus 3 will give me plus 6. Okay, and that's clear. So let's move on. So we've done the square and the r dt. Don't forget that we have to differentiate what? R twice to get acceleration. So this is our answer for the first derivative of r. So let's differentiate the second time. Okay, that will give me what now? The square r over the t square. And second derivative of displacement is what now? Acceleration. Okay, so let's differentiate again one more time. So this part here will give me 2 times 3 will give me 6. So this will give me 60. Differentiate this part to give me 0. So we have 60i. Okay. Differentiate this part. Now we did it up here. When we differentiated e raised power minus 2t, what did it give me? It gave me minus 2 e raised power minus 2t, isn't it? So to give me the same thing here, then multiply it by that. This part, this part, this part, we got what? This part, if you differentiate it, you get everything over here. So multiply it by 6, that'll give me minus 12 e raised power minus 2tj. All right, then plus, let's differentiate cos 5t just like we did sine 5t. So cos 5t, differentiate the inner function, that will give me inner function will give me 5. Differentiate the outer function, let's come back here. When you have cos x and you differentiate cos x to give you minus sine x. So differentiate cos this now, give me minus sine 5t. So everything here give me minus 5 sine 5t. Okay, so minus 5 sine 5t. Let me change the color for that. This part here is minus 5 sine 5t. Okay, so multiply that by 10. That will give me minus 50, right, sine 5t. And this is our acceleration because we've divided 2 times now. So acceleration now is equals to 60i minus 12 e raised power minus 2tj minus 50 sine 5t. Actually, and don't forget to, for the new student, don't forget to subscribe to the channel. That's the only way we generate a little revenue for ourselves. The class is free, so that's the only way we generate a little revenue for ourselves. So do well to, don't take anything from me, to just give a thumbs up, and don't forget to also turn on your notifications, so whenever we have a video like this, you can be privileged to be a part. So we've gotten our acceleration. We've gotten our acceleration. This here is our acceleration. Okay, they now said at what time? They said at when t is what now? 0. So let's solve when t is 0. So wherever we see t now, we put 0. This will give me a equals to 6 into bracket 0 I minus 12 e raised power minus 2 into bracket 0 j, then minus 50 sine 5 into bracket what now? 0. So let me rub off. Let me clear this part of my board. So a now will be equals to everything here will give me what? 0. So this one is gone. Here, this one here will give me minus 12 e raised power minus 0, which is the same as what? E raised power 0, okay? E raised power minus 0, whatever. J, okay? Then minus 50 sine 0. Don't forget sine 0 is what? Is 0. That means everything here will give me 0. So what do I have left? I have a to be equals to minus 12 e raised power minus 0 j. So punch your calculator. But I'm punching mine here. Punch your calculator. When you press e raised power minus 0, you get 1. You get what? 1. So my a now will be equals to 12 times 1 times j, which will give me minus 12j. So my a is minus 12j. My a is minus 12j. Okay, so the answer is a, minus 12j. I believe this is clear. I know it's a little bit, just go through it again so you get the calculation. So let's move on to the next. Let's move on to the next. Take a second of your time and go to your WhatsApp and share. Okay, share the link to your friends so they can join as well. Share the link to your friends so they can join as well. So let's go to the next question. Next question. Let's go to the next question. All right, I want us to finish all the questions on this part before I move to another part. Okay, I think I'm seeing one here. Okay, let us see this question. Let's see this question. We don't say a ball is thrown vertically upward. The quantity which remains the same is dash. The quantity which remains the same is dash. What remains the same when a ball is thrown vertically upward? Okay, what remains the same? One, let's start with the first one. They said displacement. They said displacement. Does displacement remain the same or does it change? This change as the ball is going up. Let me just draw. Let me scrabble a little ball. So as the ball is going up, I don't know why my ball is orange, but well, Chavi is black. As the ball is going up, what is changing? The distance that is traveling that is traveling in that direction changes. So the answer is not what displacement. Okay, does the speed change? Okay, let's see. Let us so the quantity which remains the same. So we're looking for what will not change. The kinetic energy of the ball, and this can change as well. Acceleration of the ball. Does the ball keep getting faster? Are we going to have a constant acceleration when the ball is going up? Are we going to have a constant acceleration? Who has an idea? Who wants to give an input? Are we going to have a constant acceleration when the body is now when the body is being thrown up? We say a is equals to ay, which is equals to what? 10 meter per second square. So, although the body will slow down, that's the velocity of the body or the speed of the body in that direction will reduce. But does a change as the body goes up? Who has an idea? Anybody who wants to answer that question? Who wants to answer that question? I'm waiting for an answer. Okay, I think no one is giving an answer. So let's just move on and not waste time. Okay, someone gave an answer. David Derry said that when a body is thrown up, the acceleration is zero. Okay, and does not change. Okay, let me correct something there. When a body is thrown up, it actually has an acceleration. It's only when a body is thrown in the horizontal direction that is when acceleration is what is zero. Do you understand what I'm saying? So the thing is that when a body is thrown up, what changes is the speed. So this will change. Okay, kinetic energy will also change, but acceleration remains constant. The acceleration when a body is thrown vertically upward remains constant. Okay, so that means that the answer here is D.